Every RV on the road has the exact same weak point when it comes to heat, regardless of brand, size, or price. A thin metal roof baking in direct sun for hours, turning the inside into an oven long before the air conditioner ever gets asked to fix it. A $16 vent modification changes how that heat moves through the RV entirely, cutting how hard the AC has to work without running a generator to power it harder. There's a specific temperature gap that decides whether this fix makes a real difference or almost none. The difference between your RV's interior temperature and the air trapped right up against the ceiling. Almost nobody's ever actually measured that gap in their own rig. We'll get to why it matters in a few minutes. This channel runs on people finding this useful enough to stick around for the next one. If that's you, subscribing to the Independence Files genuinely helps. It's how a channel like this keeps going. Running an RV air conditioner off a generator burns real fuel fast, typically half a gallon to a full gallon of gas per hour depending on the unit, which adds up quickly across a full day of boondocking in the heat. And that's before counting the noise, which defeats a lot of the reason people go off-grid in the first place, or the wear on a generator running under heavy AC load for hours at a stretch. There's also a compounding cost that rarely gets factored in. An AC unit forced to fight constant radiant heat from the ceiling runs longer per cycle and cycles more often overall, which means faster wear on the compressor itself. RV air conditioners aren't cheap to replace. A unit fighting an unnecessary heat load every single day is simply going to reach that replacement point sooner than one that isn't. Here's what most RV owners never think about. Hot air doesn't spread evenly through a cabin. It rises and collects at the ceiling, exactly where an RV's thin roof and minimal insulation let outside heat radiate in hardest. A standard RV roof vent, left in its factory configuration, does almost nothing to release that trapped ceiling-level heat. It simply sits there, sealed, while the hottest air in the entire RV sits stagnant just above head height. So here's the real question worth asking. If the hottest air in an RV never actually reaches the air conditioner's return vent because it's trapped near the ceiling while the air conditioner pulls from lower down, how much of the air conditioner's workload is spent cooling air that's already cooler than the air actually making the cabin feel hot? Think of it like a pot of water on a stove with the lid on. The steam collects right under that lid, trapped, building up heat pressure with nowhere to go. Crack the lid slightly, and that trapped heat escapes immediately, even though the burner hasn't changed at all. An RV roof vent modified to actively exhaust that ceiling-level hot air works the same way. It's not adding cooling, it's releasing the heat that was never able to escape in the first place. Mechanically, this comes down to convection, the same principle that makes hot air balloons rise and attics bake in summer. Warm air is less dense than cool air, so it naturally rises and pools at the highest point in any enclosed space. In a standard RV, that pooled heat has nowhere to go once the roof vent is closed, so it just keeps radiating back down into the living space, forcing the air conditioner to fight a constant, self-renewing heat source sitting right above everyone's head. This isn't a new discovery specific to RVs. Attic ventilation in stick-built homes has relied on exactly this same convection principle for generations. Ridge vents and gable vents exist specifically to let hot, rising air escape a roof cavity before it radiates down into living space below. RV manufacturers building lightweight, thin-roofed vehicles inherited the exact same heat-trapping problem homes have always had, just in a much smaller, much less insulated box. Home builders learned this lesson the hard way decades before RVs existed in their current form. Early attic designs without adequate ventilation regularly reached dangerously high temperatures in summer, damaging roofing materials and driving up cooling costs for the living space below. The ridge and soffit venting system that eventually became standard in home construction wasn't a design preference. It was a direct response to measuring just how much heat a sealed, sun-exposed cavity could trap. What changed for RVs specifically is that weight and cost constraints pushed manufacturers toward minimal roof venting compared to a house. A home can afford heavy ridge venting hardware that would add too much weight and cost to a towable trailer or motorhome, so RVs shipped with much smaller, passive vents instead, adequate for basic air exchange but not built to actively purge serious heat buildup. Manufacturers of upgraded roof vent fans, the kind built with a reversible motor specifically to exhaust rather than just passively vent, publish airflow ratings in cubic feet per minute, the same measurable spec used to rate any ventilation fan. That's a direct, testable number, not a vague comfort claim. Recreational vehicle owners in boondocking and full-time living communities who've measured interior temperature before and after adding active roof ventilation report consistent results. Interior temperatures dropping several degrees within minutes of running the modified vent, particularly in the hottest part of the afternoon when ceiling heat buildup is at its worst. Some of these same owners have compared results across different roof colors and insulation packages, and the pattern lines up with what the underlying physics would predict. Recreational vehicles with darker roofs and thinner insulation see a larger, faster temperature drop once the trapped ceiling air is released, simply because they had more heat built up to begin with. 3 separate threads pointing the same direction. Decades of home attic ventilation precedent using the identical convection principle, direct manufacturer airflow specifications, and consistent temperature drops reported by recreational vehicle owners measuring their own rigs. That's a converging pattern, not a single anecdotal claim. It's worth being precise about what varies here. The exact temperature drop depends heavily on RV size, insulation quality, roof color, and how hot the ceiling air actually gets to begin with, so there's no single guaranteed number that applies identically to every RV. What's consistent is the underlying mechanism and the direction of the effect. So if venting trapped ceiling heat is this straightforward, why don't RV units ship with active exhaust venting standard? It comes down to cost and universal fit. Manufacturers build to a price point across an enormous range of climates and use cases, so a vent upgrade that matters enormously to a summer boondocker in Arizona is dead weight to someone who only camps at hookup sites in mild climates. Building it in as standard equipment means charging every buyer for a feature only some of them need. There's a simpler reason underneath that. 2. Dealers sell RV units based on floor plans, appliances, and finishes buyers can see and touch in a showroom, while a roof vent's airflow rating isn't something that sells a walkthrough, even though it matters enormously the first hot afternoon parked off-grid. As for what this actually involves, a reversible roof vent fan upgrade, replacing a standard passive RV roof vent, typically costs around $16 for a basic manual reverse model. It mounts into the same roof vent opening most RV units already have, wired into the existing 12-volt vent fan circuit already present in the ceiling. The mechanism mirrors the pot lid principle directly. Run the fan in exhaust mode, and it actively pulls that pooled, superheated ceiling air out through the roof opening, drawing cooler air in through windows or lower vents to replace it. A continuous exchange that keeps hot air from ever building up long enough to radiate back down into the cabin the way it would with a sealed or passive vent. Now, back to that temperature gap from the start, the difference between your recreational vehicle's ceiling air and the air at head height. That gap is often far larger than people expect, sometimes 15 to 20 degrees or more on a hot, sun-baked afternoon. The larger that gap, the more this fix actually matters, because it means a huge amount of trapped heat is sitting just above the air conditioner's reach, radiating down continuously. There are honest limitations here. This doesn't replace the air conditioner, it reduces its workload by removing a major heat source, but it won't make an RV cold on its own in extreme heat. It also depends on having somewhere for replacement air to enter, whether that's cracked windows or a second vent. Running it in a fully sealed RV limits how much air it can actually exchange. Fan noise is worth mentioning too, since it's a real trade-off some owners overlook. A reversible vent fan running continuously adds a low background hum that some people barely notice and others find genuinely bothersome overnight. Running it during the hottest afternoon hours and switching it off for sleep is a common compromise among owners who've tried both approaches. Roof color and insulation quality still matter enormously on top of this. A dark-roofed, poorly insulated RV will see a bigger gap and a bigger benefit than a white-roofed, well-insulated one starting from a cooler baseline. And this won't help at all with humidity, only with radiant heat buildup, so muggy climates will see a smaller comfort improvement than dry, hot ones. Wind conditions outside also affect how well this works in practice. Strong crosswinds across the roof opening can occasionally interfere with a fan's ability to exhaust air efficiently, and parking orientation relative to the sun changes how much ceiling heat actually builds up in the first place. An RV parked with its widest roof section facing full afternoon sun will see a larger benefit than one parked in partial shade. This isn't a substitute for shade, insulation, or the AC itself. It addresses exactly one overlooked heat pathway, trapped ceiling air, nothing more and nothing less. Which loops back to where this started. The same trapped heat principle applies just as directly to a tow vehicle's cab left parked in the sun, where cracking windows and venting ceiling-level heat before running the AC cuts down exactly the same kind of wasted cooling effort. Most of the heat fighting an RV's air conditioner isn't coming from outside right now. It's heat that's already inside, trapped with nowhere to go. If you've measured the temperature gap in your own rig, or you're wondering whether your specific RV would benefit from this, drop it in the comments below. I read all of them, and I'll do my best to help you figure it out.